This is my Lab 4 report for Physics 2212 circuits. For the system, it was just the whole circuit, everything in it, and the surroundings was everything else, the atmosphere, the earth. The initial conditions were all assumed to be standard, temperature, pressure, everything. The procedure was setting up a circuit to match the image and measuring the current and volts in different ways in different places, finding different potentials. And then for part two, the batteries, capacitors, and the light bulb were connected in a series circuit, and we just noted the brightness. The capacitor was then discharged on the light bulb. The purpose was to predict the behavior of circuits containing resistors in series and parallel, to use multimeters to measure actual values of conventional current and potential differences in the circuits, and to examine the behavior of ohmic resistors and capacitors. Needed principles are the energy conservation, current conservation, Ohm's law, and series and parallel circuits. The results found in part one are the three graphs showing the potential differences in the bottom left, and then the volt changes in the potential differences in the top right, the current changes in the bottom left, and the measured current in the top left. The results in part two preview was just the capacitor discharging from 0 to 1.95 volts while charged to the 10 ohm light bulb, which just means it basically lost about 2 volts of charge. For the results of part one, the charge and energy conservation in series circuits, the ammeter's first recordings were 18.9 milliamps, which was right about where we predicted, which was 20 based on the V equals IR, which gave us 20 milliamps. So that was close. The connection was reversed, and the only change was it was now negative. The voltmeter was added to the circuit, and the only difference was that the volts was measured to be 1.467 volts, which makes sense with 1.5 volt battery. The sum of the individual potential differences for a round trip should be 0, and it was measured to be 0 by the ammeter, or the voltmeter, sorry. The measured current is shown in the top left, and the approximate graph of potential is shown in the bottom left. The voltmeter being attached to the circuit does alter it, but it doesn't change the ammeter reading because volts are very high resistance, so almost no current flows through it, making the current essentially the same. When the voltmeter was attached across the 100 ohm resistor, the ammeter did change a little bit because the voltmeter was a resistor, but so was the actual resistor, so more flowed through, and it was about 16.8 milliamps left. The voltmeter was replaced with an ammeter, and the current increased notably because the current chose to flow through that rather than the resistor. The resistance of the four components was 46.7 for the 47 ohm resistor, 98.3 ohms, 0 ohms, and 0 ohms, which is all justifiable and very close. For the results of the second part, the light did turn on and got bright and then dimmed as the capacitor got full. When it was first connected, the capacitor was charging, so the bulb brightened, but then the current was blocked. But when you flip it, take out the battery, the capacitor changes directions in the battery. The light bulb once again lights up, but the discharge is quick as the capacitor didn't have a ton of charge, and the discharging was plotted in the graph. The what if questions are basically the virtual versus lab. And in the virtual, the simulation is going to be perfect. No resistance is going where it's not supposed to go. All connections are perfect. All human error is non-existent. So basically those things just affect it and change the numbers a little bit, slow down the discharge for the second one. Possible sources of error were imperfect voltages resistance in the current circuit, the imperfect connections and other human errors, and the multimeter measuring errors and voltmeter drawing some amount of current. The purpose was fulfilled as we were able to make predictions, test the predictions with the multimeters, and learn about the properties in the circuit.